asked in the maths class, where are we going to use this? Now today I'm going to show you where are you going to use differentiation. It's mostly in physics where it sort of pops up. But you will always get a question in every exam, every test, where you have to apply your knowledge of differentiation in order to answer a question. You'll always get a question on this. So we are going to do 2 lessons on the application of differentiation. Now first let's go through all the theory. They will ask you, determine the value of x for the maximum or minimum volume or the maximum or minimum area, etc. Then you must remember that maximum and minimum you will find in the parabola and the cubic function, because the parabola has a maximum or a turning point or a minimum or at the turning point, and here we have local maximums and local minimums. And how do we get to those max or mins? We take the first derivative and set it to 0. But now they will give you an equation for distance and ask you what will be the maximum or minimum speed. So you have to look carefully with which word do they couple? Do they touch the max or minimum with? Is it max or minimum volume? Or is it max or minimum height? Or is it max or minimum area? And then when you've got that word, you must know that this one is the formula that you have to get first derivative of. Okay. Sometimes they give you a mixed question where they put in speed, the equation of speed and the equation of height and the equation of whatever, and then they ask the max or minimum area. Then you don't get the first derivative of speed and height, you get the first derivative of area. Okay, do you understand what I mean? The second thing that you should know is when they ask you to determine the rate of change of motion, there are 3 things that you should know. The first equation will be distance, height, or displacement. That is S of t. When you put a little bit of time into distance, height, and displacement, you get speed or velocity. And when you are up to speed and you put a little bit more time into speed or velocity, you get acceleration. Okay. And to get from distance to velocity, you differentiate. And to get from velocity to acceleration, you differentiate again. Okay. Do you understand what I mean? Okay. And remember, when you have to calculate this, don't forget the units. Distance is meters. Velocity or speed is meter per second. Acceleration is meter per square second. Okay. These are all on your notes. The other thing that I can ask you is to determine the average change of tempo. When you see average, you must immediately know it's the normal gradient. You can either work it out with this or with this. But when they ask you the immediate change of tempo, this word, immediate, you know it's the limit, the first principle, or you use the first derivative. These are all on your notes, so you must learn those options. You must also know the table on page 67. all those equations and formulas you must know. They won't necessarily give it to you. Okay. Now let's get to exercise 14.
And like exactly for immediate would be plus 5 is it always where direction to 0. So just say where it turns 0.
Yes. But rather use the first derivative. That's easier and shorter. Let's now do the example. Actually, the first one of your homework. Exercise 14, number 1. They say that the perimeter of a rectangle is 100 centimeters. In other words, if I go around the rectangle, the distance all around it will be 100 centimeters. Now they ask, give the dimensions. What is dimensions? Of what? Of the rectangle. So you must give what? Give what?
The sizes on the side.
Yes, the sizes of the sides. So you must get the length and the width or breadth. Okay. So they want length and width of the area of the rectangle, but which will maximize the area. So with which word does maximize go? Area. So which one must we differentiate? Area. Alright. But do they want the differentiation of the area? No. They want length and width, or length and breadth. Which word do you use? Breadth. Good. So we start with what they give us. We start with the perimeter. The perimeter is 100 centimeters. What is the formula for perimeter? 2 times length plus 2 times breadth. Okay? But they also tell you what the perimeter is, what it is. It's 100. And if you look at that formula, you'll see you have 2 variables, length, breadth. And in differentiation, we only want to differentiate one variable. Okay? So we either need to get length alone in terms of breadth, or you have to get breadth alone in terms of length. So let's take length. So we say, we isolate the length. 2 lengths is 100 minus 2b. I just shuffle it. Then I'm going to divide by 2 to get the length. We know the breadth is the breadth. Okay. So now we have the 2 dimensions, but in terms of b. What do they want? They want maximize the area. So we need the area. What is the area's formula? Length times breadth. Just to say that the breadth is the breadth. We didn't change that. Okay, you don't have to write that. Okay. So the length has a value. It's 50 minus b. And breadth has a value. It's b. Substitute that in, and we call it area with the variable b. Why do I do that? Because I have to differentiate this formula and it has to have a name. You can call it fx, whatever, but it must be fb because we have a b. Then you multiply in, and then you have the area's formula in terms of b. But to get the maximum area, I have to differentiate area. There it is. one mark, for one definite mark, you always have to write the following. For a maximum area, set the first derivative to 0. You'll get a mark for that. So that the marker knows that maximum goes with turning points. How do you get a turning point? Set the first derivative to 0. And then you do that. So you take your first derivative and set it to 0. Now you calculate B. B will therefore be 25 centimeters.
And how do you know that the breakpoint
We'll see later. I'll get back to your question. Okay. So if B is 25, can we calculate L, the length? Yes, I have a formula for length. It's 50 minus B. So the length will be 25 centimeters. And that's what they asked. They asked the dimensions, so the breadth and the length, which will maximize the area of the rectangle. Maximize means I had to differentiate it and set it to 0. So there's our first answer.
Is this a rectangle?
That's question C. Look at question C. Ah, it's not a triangle. Okay, now they want the maximum area of the rectangle. What is area's formula? So the max area will be also length times breadth. We have the maximum dimensions. So we substitute that in and we get our maximum area of this rectangle. Now they ask in question C, what type of rectangle is that? It's a square. It's not a triangle.
Can you see a rectangle? Is it quadrilateral?
Okay, a thinking question. What if I asked what is the minimum area of this rectangle? What would you have gotten for the minimum? Minimum area.
If isn't it if it's a thing.
Okay, think of the answer in question C. What is the maximum area of a square? Length times breadth. But it's the same. So what is the minimum area of the square? The same. You would have gotten the same answer because it's a square.
A square doesn't change.
No, the square doesn't change.
This one gives the same answer.
It will gives you a change. Okay. Your homework for tomorrow. Homework. You have to do exercise 14, questions 2 till 4, as well as Thursdays and Fridays homework. We talked about it on Friday and Thursday. I told you you had 4 days and you had 12 sums. So 3 a day. Did you do 3 a day?
You can take them now.